Hi students, in this video we're going to talk about circles. I understand that it is not an easy topic, so I will attempt to make the concept easy to digest, and we'll be doing some O-level questions. Right, let's start off by having the x and the y axis, and of course a circle, and this circle has center C, where the x coordinate is A and the y coordinate is B. The circle has radius r units. Imagine you're a point P that travel on the circumference of the circle, and you have x coordinate as x and y coordinate as as y. So there are two ways of expressing the equations of the circle. The first one is called the standard form. Right, the standard form is such that where A and B represent the center of the circle and R is the radius of the circle. Right, so from the standard form, when you expand these two terms, right, you'll be able to get the general form. The equivalent form is called the general form, right? And the general form is given as such on the screen: x squared plus y squared plus 2gx plus 2fy plus c equals to 0, where the center is a negative g negative f. The radius is square root f squared plus g squared minus c. Right, so we'll be doing some examples on how we can apply these two different forms, the standard and the general form. Right, let's look at the basic one. Right, so we asked to find the equations of the circle and standard form that satisfy each of the following conditions. Okay, part A, we have a circle with center O of 0, 0 and radius 6 units. So if you have a circle with center 0, 0, it means this is how your circle will look like. Right, so let's write down the formula for the standard form of a circle. So which is bracket x minus a close bracket squared plus y minus b close bracket squared equals to r squared. Right, so let's just substitute in the values for a. In this case here is 0. And the radius is 6. Right, so we can't leave the answer as such. We need to simplify it, which is rather easy because x minus 0 will just give you x. So x to the power of 2 will give you x squared. And of course, 6 squared will give you 36. So therefore, this is the standard form of the equations of this circle with center 0, 0 and radius 6 units. Right, let's look at the next questions. In these questions here, you're given the center of the circle, which is 4, negative 3. However, you're not given the radius, but we are told that this particular circle passes through a certain point, that it passes through the origin. Right, so what it means is that if you're going to have a sketch, okay, of how the circle looks like, the center is 4, negative 3. So it will be, let's say, this point here. And it passes through the origin. It passes through the origin means the point 0, 0 lies on the circumference, of the circle. Okay, so this is basically how it looks like. Okay, so from this particular point here to the center, this will give you the radius of the circle. So I'm going to show you two different ways of doing it. All right, the first way is that substitute the value of a to be 4, the values of b to be negative 3 into your equation. Which is x bracket x minus a close bracket squared plus bracket y minus b close bracket squared equals to r squared. Right, this equations you have to remember it. So that will be x minus 4 plus y minus bracket negative 3 equals to radius, which you do not know. Okay, so we can just leave it alone. Right, so let's simplify further. And this will give you plus 3. Alright, so one way of finding the value of your radius is to substitute the point 0, 0 into the equation, because the point 0, 0 actually lies on the circumference of the circle, right? So it actually satisfied the equations of the circle. So we're going to substitute x to be 0 and y to be 0 to the above. So you would have 0 minus 4, 0 plus 3 gives you r squared. And if you were to simplify it, you will have that will be 16, right? That will be 4 squared, 16, 16 plus 9, 25. 3 squared is 9, 16, yeah, okay? So in this case here, the equations of the circle will be okay. So that is the first way of doing it. The second way of doing it is right from this diagram here, right? We understood that to find the radius of the circle, right, you just have to use the distance formula. So we just label this as x1, y1, and this as x2, y2. And then you can just find the radius using your distance formula, which is square root of your bracket x1 minus x2 squared, y2 minus y1 squared. Okay, so just substitute inside there. So your x1 will be 0, minus away 4, plus y1 to be 0 also, minus 3, that will give you positive 3, and that will give you square root 16 plus 9, that is 25. 16 plus 9 is 25, and that gives you 5. So that means the radius is 5 units. So putting all this information into your equations of the circle, you would get x minus 4 bracket squared plus y minus 3 give you y plus 3 squared gives you r squared, which means you have to square your 5, that gives you 25. And you see that you get the same answer as the first way, right? Right, let's look at some important angle properties that we need to take note of when you revise this chapter. Yes, when a line makes a circle at one point only, then the particular line is called a tangent to the circle, and the point of contact is called the point of contact. So the point of contact basically is the intersection point of the circle with your tangent line. So sometimes the question will require you to find this point of contact. All right. And if you were to look at the diagram carefully, you will see that the radius and your tangent line are perpendicular to each other. Right, so usually you'll be given the gradients of the tangent line, and with that you can find the radius, the gradient of this line here that's perpendicular to the tangent line. Actually, the line that's perpendicular to your tangent line is called the normal line. Okay, when two lines are perpendicular to each other, right, and if this one is called the tangent line, then the other one will be called the normal line. Right, and if you were to recall in the chapter on coordinate geometry, right, if I let the gradient of this tangent line be m1, the gradient of normal line be m2, then you can just find m1 equals to negative 1 divided by m2. There's a negative there. A lot of folks forgot to put the negative there. Or you can find m2 if you're given m1. All right. And the conditions of the particular perpendicular lines is, if you can find, usually we can just solve it, use the concepts of the gradients of the perpendicular lines, and we can actually go on to find the equations of the circle. Right, so let's look at this question. This is a question that come from the year 2016. It's the O-level questions. Right, so you're given this, that the general form of the equations of the circle. Right, so this particular circle, it's a C1 with center A, right, and you're asked to find the coordinates of A, which is the center, and also the radius. Okay, so what we need to do is you have to compare these equations, the general form, with the general form that we learned earlier on, which is x squared plus y squared plus 2gx plus 2fy plus c equals to 0. Okay, so in this case here, let's bring your 95 to the left hand side. Okay, right, so we see that if you do a comparison, right, okay, that will be equals to your 2gx. Alright, so usually I will advise my students to divide it into 3 columns, okay, right, so that I can let 2gx equals to negative 4x, and from there I divide by 2x on both sides. I will just get g equals to negative 2, right, and then my 2fy is equals to negative 2y. I divide by 2y on both sides. I'll get negative 1, and c is equals to negative 95, and to find radius, the formula is g squared plus f squared minus c, so that will gives you bracket negative 2 square root bracket negative 1 square root minus bracket negative 95, and this you can use your calculator to work this out, right, and that gives you 10. Okay, so from there the centers of your circle will be negative g comma negative f, so that will gives you negative your g is negative 2, so negative times negative become positive. F is negative 1, so negative times negative also give you positive, and then your radius is equals to 10 units. Okay, so this is how you can solve it using the general form. Of course, another way of solving it is to perform completing the square for this. But if you're not strong in completing the square, I would advise you just to memorize the general form. Okay, right, so that's part I. Right, so let's look at this question. This question is is O-level questions from the year 2016. Okay, so the first part of the questions is asked to find the coordinates of A, which is the center of the circle, and the radius of the circle. So you're given the general form. See, this is the general form of the equations of the circle. Right, so we're going to compare it with the general form, that is your x squared plus y squared plus 2gx plus 2fy plus c equals to 0. Right, so in this case here, we will need to rewrite this as x squared plus y squared minus 4x minus 2y minus 95 equals to 0. And so let's do a comparison. Alright, comparison as in like 2gx compared with negative 4x, and then your 2fy, okay, compared with negative 2y, and then the values of c compared with negative 95. So with this, we can go ahead and find our unknowns g, f, and c. So usually I would advise the students to divide it into 3 columns like that. So the first one is 2gx is equals to negative 4x, and if we divide both sides by 2x, you have g equals to negative 2, right, and then 2fy is equals to negative 2y, divide by 2y on both sides, f is equals to negative 1, and of course c is equals to negative 95. From there I can find my radius, which is square root of g squared plus f squared minus c. And if you use your calculator to work this out, that is equals to 10 units. So therefore, the center of the circle A is negative g negative f, which is equals to 2 and 1, and then the radius is equals to 10 units. Alright, so this is how you do part I. So for part 2, you're asked to show that the point lies on C1. Alright, there are two ways of doing it. One way, it's okay, what it means here is that you have a circle, right? And we found the center A to be 2, 1. What we are saying is that if, supposing, we don't know yet, supposing the point P lies on the circle, so what we're saying is that this distance AP will be equals to the radius of the circle, which is 10 units. So this is one way of looking at it. Another way of looking at it is that I'm going to substitute 10 to be into the substitute x to be 10 and y to be 7 into the equations of a circle. And if I were to get 95 on the right hand side, means that this point actually satisfies the equation. So if the point satisfies the equation, means the point lies on the circle. Okay, so you can choose method 1 or method 2. All right. So I'm just going to show you how we can do method 2. Method 2 is easier because it's just going to substitute x equals to 10, y equals to 7 into the equations. All right, so let's do it now. So part 2, we're just going to substitute x equals to 10 into the equations of the circle. So I would have bracket 10 squared plus bracket 7 squared minus 4 times 10 minus 2 times what? 2 times. And this, if you use your calculator to work this out, you actually get 95, which is the value you get on the right hand side of the equation. All right, so we need to do an explanation. You can just leave it like that and say, oh, the point lies. So we need to say that since P comma a P bracket 10 comma 7 satisfy the equations of the circle, okay, so the point lies on C1. All right, so that's how you do part 2. Right, so let's look at part 3 of the questions. So for part 3 of the questions, we're asked to find the equations of a tangent line at the point P. Right, so to find equations of a tangent line, the general form of equations of a straight line will be in the format y equals to mx plus c. So I need to find the gradient, and I also need to find the values of c. All right, so I'm given the point of contact. So your P is actually the point of contact, right? And the tangent line, as what we have learned earlier on, is perpendicular to the radius. All right, so if we can find the gradients of AP, we will be able to find the gradients of a tangent line. So let's find the gradients of AP first. So the gradient of AP, do you remember the formula to find gradient given 2 points? Yes, so the gradient of AP, the formula will be y2 minus y1 over x2 minus x1. So that will give you 7 minus 1 over 10 minus 2, and that gives you 3/4. Right, so therefore the gradient of your tangent line will be -1 divided by 3/4, and that gives you -4/3. Okay, so with that we can find the equations of a circle, equations of a tangent line, and I'm going to use this formula to find equations of a tangent line, which is y minus y1 equals to gradient bracket x minus x1, where your x1, y1 is your point of contact, which is your 10 comma 7. Okay, so I'm going to substitute that into the equations to get y minus 7 equals to your gradient, which is negative 1/3 bracket x minus 10. So that simplify further. That will gives you y equals to negative 1/3 x plus 40/3 plus 7. And that will gives you y equals to negative 1/3 x plus 61/3. So this is how we find the equations of the tangent line at point P. Right, so let's look at part 4. So part 4, there is a second circle, C2, such that C2 has diameter AP. So the diameter, that means the radius of your C1 is actually the diameter of your C2. In other words, what do you think the size of C2 would be? What do you think is the locations of this circle C2? Yes, this C2 would have to be smaller than C1, right? Because since the radius of your C2 is the diameter of your, since the radius of the C1 is the diameter of the C2, then obviously C2 must be inside your C1. This is C1. So C2 have to be inside your C1, and it has to be have diameter AP. So how do you think you can draw the diagram? Where do you think the circle has to be? Yes, okay, your C2 will have to be that. And why do I draw it there? Because if you look at part 4, you're asked to find the equations of a tangent to C2 at point P. That means this tangent line, that this point P has to be the point on the both circles on C1 and C2. So therefore, you see, I can't draw your C2 here. If I draw your C2 here, then your tangent line will have to be here, which is this point of contact is not P anymore. You get it? So it has to be at the other side, where point P must lies on your C1, also lies on the C2, because we later on we're talking about the same tangent line. Okay, right. So let's look at part 4 first. So to find the equations of a circle, I need to know the center of the circle, right? And since your AP is the diameter, then of course the center of your C2 will be the midpoint of AP, right? So therefore, the center of C2 is equals to the midpoint of AP, which if you were to recall, the formula is x1 is plus x2. Right, so you can label your this guy as x1, this as y1, this is x2. Okay, very fanciful writing. Alright, so that will be 2 plus 10 divided by 2, 1 plus 7 divided by 2, and that gives you 6, 4. Okay, that will be the center of C2. And we also need to know radius, right? We need to know the radius. So the radius, you can actually find your distance AP, then divide by 2. So the radius of the circle will be equals to half times your distance AP would be half times square root. Alright, so that will be 2 minus 10 squared plus 1 minus 7 squared. Right, give you 5 units. So with this information, you can just put into the standard form to find the equations, which is x minus a, the center, this is your value for a, it's a value for b, This is a value for r. So that will be x minus 6 bracket squared plus open bracket y minus 4 close bracket squared equals r squared. So 5 squared gives you 25. Right, so for part 5, the equations of the tangent to C2 at point P, you see that we are referring to the same tangent line and same point of contact. So therefore, the equations will be the same as what we found earlier on for part 3. So that is the reason why you must get the diagram correct. If you don't get the diagram correct, then you won't realize that we are talking about the same tangent line. So therefore, the equations for tangent to C2 at P is the same as the value we got earlier on, which is y equals to negative 4/3 x plus 61 over 3. Okay, because it refers to the same tangent line. Right, another very important concept that we need to take note of is, supposing if you have a circle and you have a chord. This is called a chord. The chord is a line that the two endpoints must touch the circumference of the circle. Right, and that's one particular angle properties of the circle. Right, is when the perpendicular bisector of the chord will pass through the center of the circle. Okay, and this is very important. This property is very important because usually we will solve the equations of this perpendicular bisector of the chord, right, with another line that passes through the center. When we solve these two equations simultaneously, that will help us to find the center of the circle. So this is a very important concept that is frequently tested. So in the next slide, we'll do one question on that. Right, so in part 2 of the questions, we are told that the center C of the circle lies on this line 5x plus y equals to 0. So if I'm going to rewrite it in the format y equals to mx plus c, you'll see that the line y equals to negative 5x has a negative gradient and it actually passes through the origin because the value of c is 0, so passes through the origin. So we can roughly sketch the line y equals to negative 5x as such. And from the diagram, we see that if we were to solve these two equations simultaneously, right, the intersection point will be the center C of the circle. So this is what we're going to do. We're going to let equation 1 equals to equation 2. Right, so therefore the center C, the coordinates of point C will be negative 1, 5. Right, so in part 3, we are asked to find the equations of the circle in general form. So we already found the center, but what it's lacking is the radius of the circle. So the radius of the circle, we can either use point A, join a line from point C to point A, or join a line from point C to point B, both of which will give us the radius of the circle. And by finding the distance, we will find the radius of the circle. So I'm just going to use find AC. So that will be negative 1 minus 2 close bracket squared plus 5 minus 1. And using a calculator, that will give us 5. Okay, right. So we're going to substitute that into the standard form first. We substitute in the standard form, then we expand it to get the general form. So the standard form will be x minus a. So this is the value I will use to substitute by a. This is the value I substitute by b, and that is the value I substitute to r. So it's x minus minus 1, so become x plus 1 squared, y minus 5. The formula is x minus a squared plus y minus b squared equals to r squared equals to 5 squared. That gives you 25. So we're going to expand it to get x squared plus 2x plus 1 plus y squared minus 10y plus 25, then minus 25 equal to 0. So that will give us x squared plus y squared plus 2x minus 10y plus 1 equals to 0. So that would be the general form of the equations of this circle. Right, let's look at the last question. In this last question, we're given a circle, right, given 2 points P, which is negative 5, 8, and Q, 1, negative 2. Both points lie on the circle, and PQ is the diameter. Right, so PQ is the diameter of the circle. Us to find the equations of the circle. So since PQ is the diameter of the circle, that means the center of the circle lies on the line PQ, and it's actually the midpoint of PQ. So let's go ahead and find midpoint of PQ. Right, which is your x1 plus x2 over 2, y1 plus y2 over 2. That gives you negative 2, 3. And after knowing the midpoint, from there we can find the radius of the circle. Okay, so we have done enough questions to know how to do this quite fast really. So the midpoint is the center of the circle, which is negative 2, 3. Then from there you can actually find the radius, which I think I use point P. Okay, because it's negative 5 minus minus 2 square root plus bracket 8 minus 3 square gives you square root 34. So with that, we can put into our standard form. Alright, because the questions do not require to express it in general form, so we can just leave it in standard form. There's no need to expand it. Right, the second part is the one that is considered advanced, because you need to explain why is it this particular line that meets a circle at point Q, it's a tangent line. So we have a line that meets point Q. We have a line that meets the circle at point Q. And why is this line that is colored red a tangent line? So this brings you to the basic concepts on the connections. All right, the connections, the relationship between your tangent line and the radius. Yes, the tangent is perpendicular to the radius, right? And if the tangent is perpendicular to the radius, then what other concepts that can we relate to? If two lines are perpendicular to each other, what other concepts you can relate to? Yes, these two gradient multiply together will give you negative 1, right? So in other words, if I can prove that the gradient of PQ, when I multiply with the gradients of the line, the red color line, equals to negative 1, and then I can convince people to say that the red line is actually a tangent line, right? Yeah, so this is exactly what we're going to do. All right, so we're going to find the gradient of PQ, and that gives you a y2 minus y1 over x2 minus x1. That gives you 10 over negative 6, gives you negative 5 over 3. And then from the equations of the red color line, we're going to rewrite it in the form y equals to mx plus c, so that we can fish out your gradient. So from here we see that the gradient is 3/5. All right, so this is what we're going to do. From here we're going to say that we're going to take negative 5 over 3 times 3/5, and that gives you negative 1. And then we need to explain. We can't just leave answer like that and assume people understand what's going on. So we explain that since the gradients of PQ times the gradient of the line 3x minus 5, we can write it like that, is equals to -1. Okay, therefore the line 3x minus 5y is equals to 13 is a tangent line. Okay, to the circle. Sorry, I need to put some caret here. At Q. Okay, so this is how we do it. And this questions complete this video on circles. I hope this video has made you understand the concepts of circle better. Good luck to your exams.